A bucket is lowered into a well and filled with water. How much work is done raising the bucket to the top of the well if the bucket filled with water weighs 25 pounds and the rope weighing 0.5 pounds per foot initially extends 30 feet into the well? So as we look at this, we know work is force times distance, but we do have a variable force because the weight of the rope is going to vary because we're wrapping this rope around here, and so the weight of the rope as it shortens is going to change. So let's go ahead and look if we'd extended this down, and we'll call this 0, and this total till we get up to the top with no rope is going to be a distance of 30 feet. Initially we'll start out down here and we've got the weight of the bucket, 25 pounds. Weight is a force. It is mass times gravity here, so we've already got the force due to the weight of the bucket, and so when we integrate this, we're going to be integrating between 0 and 30. That's our distance, and that's in feet, and we've got our force, which is 25 pounds for the full bucket, plus 0.5 pounds per foot multiplied by how many feet. Now as we look at this, if we start at 30 and we're going to let x be, it's vertical, but we'll just call it x here, so this will be starting down here at 0, the distance that this travels, and so 30 minus x would tell us how much rope we have. Down here at the bottom we've got 30 feet, up at the top 30 minus 30 we have 0. So there, this would give us our force due to the weight of the rope, and then we have our little distance dx. We can simplify this a little bit, so we have 0 to 30, and here we have 25, and if I multiply this, that would give us 15, so that's going to be 40 minus 0.5x dx. So we can do an antiderivative here. We've got 40x minus, this would be 0.25x squared, and we'd need to evaluate that from 0 to 30. So I've got 40 times 30 minus 0.25 times 30 squared, and then typically we'd subtract off evaluating at the lower limit, but we can see that that's going to be 0. So I'm going to come up just above it so I'm not off the screen here. When I compute that, we'd have 1200 minus, this would be 900 divided by 4, so 225. 1200 minus 225, which would be 975, and the units are foot-pounds. We know we had units of work, if we were using newtons and meters, would have been in joules, but when we're using feet and pounds, it is just foot-pounds.